Alright, so up next for us will be the multiplication and division of SURDS. Now, we're starting with multiplication of SURDS. Okay? Now, I'll be looking at multiplication of SURDS in two forms. I'll be looking at multiplication of simple SURDS and the multiplication of compound SURDS. So let's see the multiplication of simple SURDS. Now, what do I mean by simple SURDS? Now, simple SURDS are singular SURDS. So, for example, if I have root m times 4, okay, let's say b root n. Alright, now the solution to this is equal to, now remember the coefficient we have here is 1. So I'll have 1 times b root m times n. So this is equal to b root mn. So SURDS in this nature, that SURDS we know as our simple SURDS. So if we have root 2 times 5 root 3, now the solution to this is equal to, coefficient here we have is 1, right? So I'll have 1 times 5 root 2 times 3. So this is equal to 5 root 6. Alright, now let's look at compound SURDS. Let's see multiplication under compound SURDS. So what is a compound SURD? Now a compound SURD simply represents two SURDs acting as a unit. What do I mean by that? If I have something like root 4 minus root 3, now acting as a unit, now it is a compound SURD. So if I have two compound SURDs multiplying out, let's say root 4 minus root 3 times root 2 plus root 5. Now how do we carry out this kind of multiplication? Now this is very, very simple. It is the same way we do our algebraic multiplications. And how do we do it? Now we'll pick one of the brackets and use everything we have in the brackets to multiply the other bracket. So it's either we pick our first bracket or we pick the second bracket, or let's say our first compound SURD or the second SURD. So let's pick the second. So it means I will use every value here, every digit here to multiply every digit here. So we'll start with root 2. Now root 2 times root 4 will give us root. Now this is 4 times 2, right? Now root 2 times minus root 3 will give us minus root 3 times 2. So we are done with root 2. So we'll go over to root 5. Root 5 times root 4 will give us plus. Okay, this is plus, this is plus. Will give us plus root 20. Now root 5 times minus root 3 will give us 15. Okay, minus root 15. So this is equal to root 8 minus root 6 plus root 20 minus root 15. Okay? Now look at this. We have root 8, we have root 6, we have root 20, we have root 15. The roots we have. Now we have complex SURDs here. And remember what we said. You are never allowed to leave a complex SURD in your answer. So what does it mean? It means you need to find the basic forms of these are complex SURDs. What is the basic form of root 8? Now the basic form of root 8 is 2 root 2 minus, now 6 is a basic SURD. It is made up of just 3 and 2, and none is a perfect square root. So we have root 6 plus, now 20 is a complex SURD. Okay, now it contains 4 perfect square roots. So this will give us 2 root 5 minus root 15. Okay, to have our final answer. To have our final answer to be equal to 2 root 2 minus root 6 plus 2 root 5 minus root 15. Alright, so now this is basically what it is. Now multiplication under, simple SURDs and multiplication under compound SURDs. Now the next we'll be looking at, basically that is it. as far as SURD is concerned. Okay? Now, the next we'll be looking at will be the division of SURDs, or division by SURDs. Division by SURDs. Now, before we start, I would like to throw us back at where we said that SURD is an irrational number. And if you remember clearly in mathematics, no irrational number has the right to divide any number. So what does it mean? It means that SURDs cannot divide any number. So basically, we don't have anything like division by SURDs. Okay? Now, so in mathematics, wherever you find a SURD dividing a number, or wherever you find a SURD dividing, its co-SURD, now you will have to rationalize that number. Why? Because that statement mathematically is not correct. So it means that in mathematics, I am not supposed to have 2 over root 5. In mathematics, I am not supposed to have root 3 minus 2. Why? Now, because I have a SURD as my denominator, and I also have a SURD as my denominator. So what do we do in situations like this? We rationalize. So we'll move from division by SURDs to rationalization of SURDs. Rationalization of SURDs. Now, how do we rationalize a SURD? Now, first of all, you can only rationalize SURDs when they're in fractions. Okay? And you can only rationalize when you have a SURD as a denominator. So if I have, alright, so in questions like this, what do? We rationalize. And how do we rationalize? We rationalize by multiplying our numerator and denominator by the conjugate of a number. And what is the conjugate of a number? Now, the conjugate of a number is the negative value of that number. What do we mean? Now, if I have 1, the conjugate of 1 is minus 1. If I have 2, its conjugate is minus 2. So if we want to rationalize this, we'll have to multiply our numerator and our denominator by the conjugate of our denominator. So I have times. Now the conjugate of root 5 is minus root 5. So I have minus root 5 all over minus root 5. Now, minus divide minus will give me plus. So we'll multiply out straight. Now remember, we've talked about multiplication in fractions. Okay? And if you don't remember clearly, or if you don't know, now I'll have to refer you back to our video under multiplication in fractions. So we have 2 times root 5 will give us 2 root 5 all over root 5 times root 5 will give us 5. So this is equal to 2 root 5 2 root 5 all over 5. Now if you look at this clearly, we've succeeded in removing a SURD as our denominator. So this number has been rationalized. Okay? So the next we'll be looking at rationalization of compound SURDs. So if, for example, I have 5 all over root 2 minus 1. Now this is a compound SURD as our denominator. Now how do you rationalize? Remember, it is still the same thing. You multiply your numerator and your denominator by the conjugate of your denominator. Now, but how do we find the conjugate of compound SURDs? Okay? Now it is very, very simple. Now we'll find the conjugate of a compound SURD is gotten when we interchange the intermediate sign, or the sign between the two numbers. So what do I mean by that? Now here I have minus. Now its conjugate will be root 2 plus 1 all over root 2 plus 1. Okay? So, and if I had plus, its conjugate will be when I change from plus to minus. So let's multiply. Equal to. Now this times this. This will give us 5 root 2 plus 5 all over. Now remember how we multiply compound SURDs. Now I'll pick one bracket, multiply the other bracket. So root 2 times root 2 will give us 2. Root 2 times 1 will give us plus root 2. So I'm done with this. Minus 1. Minus 1 times root 2 will give us minus root 2. And minus 1 times plus 1 will give us minus 1. This and this cancels out. To have 5 root 2 plus 5 all over 2 minus 1. So this simply is 5 root 2 plus 5. Now all over 1, which is still 5 root 2 plus 5. Final answer. Okay, so now that is basically what rationalization of SURDS is all about. So what did you say? Now I want us to recap this. Remember we said in SURDS there is nothing like division by SURDS. Okay, now once you see a SURD dividing any number, just know that that number is irrational. And whenever we meet an irrational number in SURDS, what are we supposed to do? We are meant to rationalize. Okay, so basically that will be it on the video on SURDS for us. So let's look, but before we shut down, let's look at 1 or 2 exercises on SURDS. The first exercise we'll be looking at will be root 27 plus 3 all over root 2. Okay, now how do we start solving this? Now this addition, okay, so the first thing to do is to carry out this additive operation. So let's add this first of all. So this is root 27 all over 1. So we'll draw our fractional line. The LCM of this and this is root 3. Now root 3 divided by 1 will give us root 3. And root 3 times 27 will give us root 27 times 3. Okay? Plus root 3 divided by root 3 is 1. 1 times 3 is equal to 3. Now, if you look carefully at this, this 27 is equal to 9 times 3. So we can have this to be root 9 times 3 times 3. Okay? Plus 3 all over root 3. Now, this is 9. 3 times 3 is equal to 9. So this is the same thing as root 9 times 9 plus 3 all over root 3. Okay? Now 9 times 9, it is 2. So it means that, and this is square root. So this square root will factor out just 1, 9. So our square root will cancel out 1, 9. To have 9 plus 3 all over root 3. Now 9 plus 3 is equal to 12 all over root 3. Okay? Now this is our answer. Now, but if you look at this, you find out that we have a SURD as our denominator. And remember what we said. It means it makes this number irrational. So what are we supposed to do to rationalize this? Now, so let's rationalize. So we'll have to rationalize 12 all over root 3. Remember what we said about rationalization of SURDS? I'll have to multiply by the conjugate of my denominator. So I'll have root 3 all over root 3. Remember, minus, minus. But minus divide minus will give us plus. Okay? So I'll have to multiply out straight. 12 times root 3 will give us 12 root 3. All over root 3 times root 3 will give us 3. So this is 12 over 3 times root 3. Now 12 divided by 3 will give us 4. So our final answer is equal to 4 root 3. Alright, so basically that will be it on SURDS. Now what, if you need more exercises, in fact you will need more exercises. So I'll ask you to follow the link below this video to find out more detailed exercises under SURDS. Now believe you me, you need this, okay? And also follow the link to see more from 500 boosters. And also for your past questions under WAEC, JAMB, NECO, GCE, POST UTME,